how to construct a stem plot, plus a few tips and tricks. The first thing that you need to be able to do in order to construct a stem and leaf plot is to identify the leaf portion of your data and the stem portion of your data. Now, the leaf portion of your data is always going to be the smallest place value. Now, in this case, my smallest place value of all these numbers is going to be the ones place. So what I'm going to do is I'm going to draw a vertical line separating the ones place from the rest of the values. All the values to the left of this line are going to act as our stem. We have our leaf portion in the ones place, stem portion, all the values to the left. Now with this first example, I want you to notice that not all our data values have the same number of digits. For example, we have numbers like 99 and 87 versus 104 and 146. Now the ones place is the smallest place value in all of these numbers, so the ones place is going to act as my leaves. Now what I want you to notice is that our stem values, everything to the left, some of them have 2-digit stems, some of them have 1-digit stems. That is perfectly acceptable. Our leaves are the only values that have to remain 1 digit. Now in this case, you'll notice that my smallest stem is an 8 and my largest stem is a 20. So my stem and leaf plot is going to have a stem ranging from 8 all the way to 20. Notice my leaf unit is the ones place, so that is just a unit of 1. Now for this next example, our ones place is still our lowest place value, so that's going to still distinguish my leaves from my stem. But I want you to notice 7 and 9. It appears that they don't have a stem. However, they actually do. If it appears that they don't have a stem or a leaf according to the way the data is split up, what I want you to do is I want you to place a 0 as a placeholder. Now I can clearly see that my stems range from 0 all the way to 6, and my leaf unit is still the ones place. In this last example, I'm going to show you a case where there's some decimal places. Now notice my smallest place value in all of this data set is the first decimal place, and so that first decimal place is going to act as my leaves. Now what I want you to notice is that down here it originally appeared that we did not have a leaf there. We did, however, we just had to input a 0. Now I can clearly see that my stems range from 95 to 99, and my leaf unit is 0.1 in this case because it's the first decimal place of my leaves. So I'm going to do that for the percent of females who are literate from our previous data set. Now to construct a stem plot, I first need to identify my range of my stems. So I'm going to clearly look at all my data values and I'm going to identify what my range of stems, in this case being my smallest stem value is a 2 and my largest stem value is a 9. So my stem is going to range from 2 to 9. I'm going to use that information to set up the left side of my graph. See, my smallest stem is 2, largest stem is 9, going vertically. Now the second step is to go through the data and write each leaf on the proper stem. Now it's important to note that this number 318 is not 318. Each leaf is attached to its appropriate stem to be its own value. And what I mean by that is, for example, this number is 29, this is 31, then we have 38, 46, there's no 50s values, then I have 60, 63, here's another 63. So it's important to note that each leaf is attached to its stem separately. Now, trees grow from the stem out, or from the trunk out, and they get larger as they expand further and further away. Now that's important to note because that tells us that we're going to reorganize our leaves so that they grow out almost like a tree would, and as they get further away from the trunk or the stem, they become larger and larger. So you'll notice that our values now go in order from the stem out. So in this case, I have 7, 0, 1, 1, 8. As I read left to right, my leaves get larger. Now the last thing to do in order to have a properly constructed stem plot is to just properly label it. So I'm going to put a nice title on here, clearly identifying what the stem plot has to do with. And then I'm also going to incorporate my leaf unit, in this case showing that each leaf represents 1%. And that would be a well-designed stem and leaf plot. Now a little trick, we're not going to quite get to describing them yet, But for when we do get to that point, I want to show you something that you can easily do with your stem plot in order to help better identify the shape of it. Now, stem and leaf plots are constructed vertically. Once again, my stem is going from the smallest value and then all the way down to the largest value. But to properly describe the shape, what I'm going to recommend you do is I'm going to recommend you turn your stem and leaf plot on its side. Now notice I turned it on its side so that the stem almost serves as a number line. Now what I can do is I can see my leaves almost acting as if they are bars or possibly like a dot plot. That allows me to better identify the general shape of the values rather than when it's in its vertical pattern. Another really useful thing about stem plots is to compare two related distributions. For example, in this case, we were talking about male versus female literacy rates. So I can easily compare these two groups, the males and the females, by doing a back-to-back stem plot. Now it's important to recognize that in a back-to-back stem plot, you're going to use a common stem. So both the male data and the female data is going to be attached to the same stem in the center. Now what we're going to do is I'm going to show you not only how to have the females placed on here, but how to also have an additional data set placed on the opposite side. We already constructed our female stem plot on the right-hand side, so we're okay on that side. However, I'm going to identify my males on the left. Now it's important to see that on my graph, not only do I have data values, but I have them clearly labeled as to which group they pertain to. If I had this male-female portion covered up, it'd be really hard to be able to tell which side was going to be the males, which side was going to be the females. Now looking at our male data, I want to just remind you that the female stem ranged from 2 to 9. But if I look at my male data here and I split it into stem and leaves, you'll notice that my smallest male stem is a 5 and my largest male stem is a 10. So notice my stem ranges are different. But I have to label the back-to-back stem plot on a common stem. So what that means is I'm going to need to have my stem range from the smallest value to the largest value between both groups. So I'm going to add this 10 down here. So I go from 2 to 10. So I already have my female data labeled here. I'm going to now identify my male data. Now notice, just like a tree or a plant would grow larger as it gets further and further out, notice that our females, sure enough, gets larger as we go to the right, but notice that my males is the same, working its way to the left. All right, so you always want to grow as you go further and further away from the stem. All right, once again, my leaf unit is 1%. I have a nice title up here, as well as my two sides labeled. Now, a couple just kind of warnings and tips and tricks. Stem plots are really kind of tedious when it comes to large data sets, but there are a couple things that you can do in order to make larger data sets more manageable. The first modification that you can do is called splitting the stem. If you have a really large data set and you construct a stem plot, it's very likely that your leaves are going to be really far out from the stem. Now, the further and further your data gets out from the stem, the harder it is to really visually capture the shape of it. So what you commonly do with large data sets is you do something called splitting the stem, which means instead of writing each stem value just once, I'm going to write each stem value twice. So notice I have 2 zeros, 2 ones, 2 twos, etc. Now, what I'm going to do here is I'm going to show you an example of this data set and how to place it on a split stem graph. Now, to put these values, my leaves, on this graph, I'm going to put my leaves of 0 to 4, corresponding to the stem 0, in this first row, and I'm going to put leaves 5 through 9, corresponding to the stem of 0, in the second row. Now, it doesn't mean I'm going to have an equal number of leaves on each row. All it means that if there's 10 digits total, 0 to 9, and there's 5 in the first row, 5 in the second row, what that means is that each row has an equal chance of obtaining leaves. It doesn't mean that that certain data set is going to have an equal number per stem leaf or per stem row. And I'm going to do that for each split stem. So what I did is I took this data set and I split it up so that, sure enough, notice This is the number 1, 3, 5, 7, and 8. Instead of all of those values being in one row, what I'm doing is I'm putting digits 0 through 4 in the first row and digits 5 through 9 in the second row. Now, one thing that you can do with a stem and leaf plot is if you ever have a value, for example, down here, this 4 doesn't have any data in it. What I can do is if there's no data there, I can erase that. Now, it's important to note, however, though, that I cannot erase this middle section in the teens here. Okay, think of it as a branch. If you cut out the middle section of a branch, the rest of it's going to fall off. But you can trim off the edges, for example, before or after. This is our after portion if I had any empty spots up here. I can trim off the edges in order to help avoid a stem plot going on forever and ever and ever. Now, the second modification that you can do is called trimming. Trimming is a way of just helping manage your data so that if you have a lot of values, a lot of digits within each data value, that it's more manageable, meaning less digits to deal with. So for example, I might have a data set with a bunch of decimals, in this case 120.7. If I wanted to trim all the data, I might just chop off all the decimal places. And that is perfectly fine as long as you are consistent with your data. I can't just chop off this decimal place of this value and leave all the other decimals in my stem and leaf plot. You can also round if you would prefer. However, once again, please make sure you're consistent. If I rounded all my data sets, this would round to 121. Now, I know with these modifications, it's kind of hard to tell when you should split stems, when should you trim, etc. But it's also, I want to kind of ease your fears by letting you know that there is not one correct way to do a stem and leaf plot. Okay, use your judgment on deciding whether to split stems or whether to trim. All you need to do is clearly state what modifications you've made so that your reader can follow your work.